Here's a solution to one of the analysis of variance problems, and we'll illustrate what it looks like when you pull the information into StatCrunch. There is one problem in there that wants the F-score to be given to 4 decimal places, and that lighter weight web app that I showed you in class that we were using does not give you 4 decimal places of accuracy for the F score. So for that one, for sure, I think it's the one that has the weird measurements in minutes and seconds that you have to convert. But that one that requires 4 decimal places for the F test statistic, you will need to do in StatCrunch in order to get enough decimal places to make the computer happy. Anyways, we have data here about download times for files at 3 different times. So we have early morning, evening, and late night times. So we have 3 groups where some data has been collected for download times. And so we have 3 population means: the mean download time at the early hours, the mean download time for the evening hours, and the mean download time for the late night hours. So that'll be our mu1, mu2, and mu3. The population means will be the average download times at each of those time periods. Again, not just the ones that the person did, but the mu's are standing for the real value of the average download times across all possible people doing it at those times. So those mu's are population means. They're not just referring to the data that we have here. So we talked about the fact that the hypotheses are always the same for the analysis of variance. H0, the mean that says there's no effect. In other words, there's no relationship between what time of day you try this and how long it takes. That would be mu1 equals mu2 equals mu3, so it's given here. And the alternative hypothesis is just the opposite of that. That's not true. The one red thing I always keep pointing out is that this is not the same thing, right? Just in terms of words, in A, this is saying that all 3 means are different, and that's not what analysis of variance is testing. There's a lot of room in between all of them being the same and all of them being different. So the correct null hypothesis for analysis of variance is that all the means are the same, and the alternative hypothesis is just that that's not true. So something is different. All right, so how do we get this over into StatCrunch? Well, there's a little do-jigger here that opens this up, and one of the options is to open it in StatCrunch, and if your browser is happy with doing that, then by all means do that. I have seen several browsers that don't behave correctly when you click that button, including mine. So here's how I always do it that works. I click the button that says open this in the clipboard, and I get a little screen that looks like this guy. So this is what I see when I say open the data in a clipboard. And so I just copy all of that, and I choose all of it with my mouse and hit copy. So for me, that's Command-C, or you could right-click and find that menu. But I'm going to copy that, the data table, and then I'm going to go open StatCrunch. So for me, the thing that works well for me is to go into StatCrunch from my MyLabs Plus, and then choose this option that says paste data into a form. And when I do that, it opens a box that just gives me a blank spot like that. And I just put my mouse in there and choose paste. Again, either Command-V or Control-V, or just right-click and pick paste. So after I do that and say load data, then I'll have those columns in my StatCrunch. Now, one thing you should know is that in these data sets, there's none of them that have very much data. So I wouldn't fiddle with StatCrunch, this loading thing, too much. You really will be done a lot sooner if you that's 6 numbers in each of 3 columns. So you really could just type that into a blank StatCrunch table, and you'd be done a lot sooner than trying to wrestle with it. Anyway, so when it's done correctly, either way, this is what your data looks like in here. You see I have those 6 numbers in each of the 3 columns. And then the right way to execute the analysis of variance is with these menu options. So stat, ANOVA, and we're doing a one-way ANOVA. We're not even talking about a two-way ANOVA. in this class. So with the data in there and making those choices, I'll get a dialog box that asks me to make sure it understands what I want to do. And I have to, I do want it to work with all three of those columns. When you did your data project, you saw an example of when all the data was in one column, but that's not what's happening here. We have three different columns, one for each group. So we pick that we want those three columns. There's nothing else we have to set in that dialog box. We can just tell it to, and this is the output that we'll see up on the top left. You can see it gives us some summary information for each of our groups. So that's kind of nice, because from that we can pretty easily see how much these sample means are different. So it's not going to surprise us at all if analysis of variance is telling us that those are significantly different. But the actual results from the hypothesis test are given down below. And again, we know what the relationship is between all of these things. But ultimately, the test statistic is there and the p-value is there. And so here in the problem, the last part of the problem is that they asked me to put the F statistic in to 2 decimal places, and so I've rounded it to 14.24. It asked for 3 decimal places for the p-value for some reason, so 3 decimal places of that is just 0.000. And then of course our conclusion is that that's small. If 0 is not small, nothing is ever going to be small. So the p-value is small, in other words, less than the significance level. So we reject H0, and so make that fit. So we do reject H0, and we do have sufficient evidence to conclude that. And again, this statement should be equivalent to HA, right? And that's always true. The only difference would be if our p-value was not small, then these do's would become do nots. So we don't ever change what this is at the end. We just say we do have sufficient evidence to support it, or we don't have sufficient evidence to support it. And again, make sure you believe that the HA the sentence that I have here really does match the HA. Oops, it's not there. Which on my computer screen is right above all this, but the HA is the thing that says that the population means are not all the same. So that's all that's being read off there. Okay, so that's it.